So welcome and okay, we have studied about solid angle. Solid angle and flux. How two things are connected we have seen. Just I am recalling you. Okay. And how we have learned how to find the solid angle of a surface. And we have also learned how to find in a spherical coordinate system. A spherical coordinate system. It was solid angle was nothing but sine theta, d theta, d phi. Okay. Theta and phi are the two coordinates of a sphere. We know that a spherical coordinate system you can express is r, theta and phi. Okay, just now today we want to study flux density. Flux density. I just want to capitalize the earlier concept so that we can advance a little bit to make an insight into the depth of this term, depth of electrostatics. Because electrostatics, when you study electric field in material, then you have to know one more term, that is electric flux density. Okay, it's a very important term that is represented by D. Suppose, let us do it. Okay, we have suppose we have point charge. This is a particle have a charge Q, then it can produce the electric field. We know that Q by 4 pi epsilon naught. You can write r square epsilon naught and unit vector r. R is the distance. What is R? R is distance from this point. You can see that r is the distance from this source charge, and it's give the directions. Okay, I'm just going to capitalize this equation. Okay, what this is telling you, can you notice one thing? This is surface area of a sphere. So when this area is going to be increased, electric field is going to be decreased. Can you get it? So this is inversely proportional to the area of the surface. Sorry, surface area of a sphere. 4 pi r square is a surface area of a sphere. Let us play with this equation. Okay, just play with this equation. I am going to capitalize this to get information, to get a beautiful information on this. We have, let's integrate both the sides. On integrating both the sides, of equations, suppose E over the surface, this is over the surface. Okay, and dr dot ds, this is the area, and both the sides you will get r unit factor q by 4 pi r square epsilon naught ds. Okay, this electric field is integrated over this surface. can get at the outside, which is constant, a square epsilon naught ds, and it is also a vector, and you can say that it is have direction of r in vector r. So we have this is equal to 1 because they are in the same direction. ds is normal to the point of ds is area vector having direction r naught, and r naught they points in same direction. So when dot product is done, we will get 1. So it can be integrated over the sphere. What will you get? Q by 4 pi square epsilon naught into area of a sphere, and this is going to be cancelled out. So what we have got, Q by epsilon naught, and this is the sphere enclosing this charge Q. Okay. So what we have found that you have performed integration of this electric field over a surface, and you are getting a constant. This is constant. Okay. You may have a bigger sphere, or you can vary this area, okay, enclosed area, but still we get the same constant result. Okay. So this is a constant. I mean to say, when you increase the R, of course E is going to be changes. When R, if I say R is going to changes, I mean to say then surface area. Suppose this is the radius R. If R is going to be changes from R, say R to R dash, then this is the surface. This is also changing, and electric field will also change because it's function of R. When R changes, E changes, but still you have integral over this surface is constant. This is very good, noticeable result. You can use this. Okay, let me do something with this equation. Just multiply with E, this constant permittivity, into ds. We have charge enclosed. This is charged enclosed. So a little modification, small modification, you see this result, and you can say this quantity as d. This is d. Okay, this is the d, and flux of this quantity is nothing but charge enclosed. Okay, you can say this flux of the electric field. Okay, when it is in vector, it is made integrable over this surface area, you get this quantity. So when this quantity and d, this is permittivity and this is the electric field, and this one is integrated over this surface area, we get the charge enclosed. And this is the, I'm talking about electric flux density, because it is different way for description of the electric field. You can find the electric field in terms of force, in terms of potential. Okay, But here we have represented the electric field in terms of flux. Well, okay, my purpose is to tell you one thing, that through flux you can find the electric field, and you can use it in different medium. When electric field crosses from one medium to another medium, then you will see the constraint. We will study later what happens there, what is certain constraint when you find a charge over the surface. Surface may be of different nature. One may be semiconductor, one may be conductor, one may be dielectric, one may be conductor. Okay, in middle, in middle this may be conductor, and this may be dielectric, and this is the boundary, and it may have a surface charge density. Then how the electric field behaves, what is the constraint? Okay, we will learn. So where this electric flux density D is going to be very useful. One more thing, that unit of D, what is going to be unit of D is charge meter square. This is surface charge density. Surface charge density. Okay, so we have introduced the same flux in same Gauss law, viewing with different angle, and get a different quantity, that is D, and it is very useful in finding the electric field in a medium. Okay, you can find D. Okay, you can easily find D with this equation with charge enclosed, and then you can find E. So let me draw it, and then we will do some numerical problems to justify my statement. What I am teaching here, and this beautiful D, how it can be applicable in electrostat, because now from 12th and standard lecture I am making for IT, because I am in transition zone. I want to jump to the stage where I can freely teach you. I can freely teach you the level where I want to teach. उस स्टेज अभी तक हमारा आया नहीं है जहां से हम लोग फ्री डिफरेंशियल इक्वेशन से इस सब चीज को डील कर सकें, जहां पे काफी हम एंजॉय करने वाले हैं उस चीज को. यहाँ पे थोड़ा सा मुझे सोचना पड़ता है कैसे बताएं, कैसे लिंक जोड़ें, ताकि हम 12th स्टैंडर्ड जो आईटी क्वेश्चन से हम पीएचडी लेवल क्वेश्चन को कैसे डील कर सकते हैं, बिकॉज फिजिक्स इज गोइंग टू वेरी इंटरेस्टेड. So we can see the Gauss law in different way. Okay, Gauss law that we have seen that D dot ds is charge enclosed. This is the flux. You can see the flux of this quantity D, and it is really, and you will find its importance after 1 or 2 lecture. Okay, then I give you easy problems here. Question: a circular disc of radius 4 meter with a charge density is given with this function sine phi microcoulomb per meter square. This is your charge density per unit area. is enclosed by the surface, enclosed by the surface S, then what is the flux? And what is the flux crosses S? Okay, this is your question. Once you will able to find the total charge enclosed by the surface, then you can really answer this question. You can flux is the thing that charge enclosed, and this is circular disc. Then you can use circular coordinate system to find this. Okay, this is the phi and the radius is r. I can write this expression as what is the area of circular disc? Pi r square. How can you get this? Okay, you can write this as r dr and d phi, and r will vary, and d phi, this is the angle. So I can write here like this, r dr. And this angle is d phi, and we have charge density del S, and d phi, it will vary from 0 to pi because it's a circle, and radius there's no need to write here, you can write exactly here, and radius is from 0 to 4 meter, and this angle is varying from 0 to 2 pi. So what will you get? This is your charge enclosed. Now you can find the flux. Well, so this is the importance, utility of Gauss law of these equations. Okay, I can write 12 sine phi d phi r dr 0 to 2r and 0 to 2 pi. Okay, and sine phi is going to be 0. You understand this integration very well. Area under curve from 0 to 2 pi is going to be 0, then whole term is going to be 0. 0 multiplied with any term will give result as 0. So you don't have any charge. What does this mean? This means charge enclosed is 0. What does this mean? Doesn't it have no charge? No, but delta S is given. Okay, charge density is given, but can you guess why the charge enclosed is 0? Because it may have equal number of positive charge and equal number of negative charge. So net charge is equal to 0. Okay, that implies that disk contains equal number of positive and negative charges. Okay, so how beautiful this thing is. Okay, you can use it in everywhere. You will see. I will make you understand how beautiful it is. And this is connecting link between from just 12th standard, because I will solve David Griffith. So I want to just make understand every term and connect link from here to there at that stage. Then it will be easy to understand it, because it will couple up and accumulated knowledge there. From every lecture, it will be easy to understand you when I will express very lucidly in differential equation term, where there no need to go for the basic for understanding. Now I am going clearly the basics. I'm making good basics, and this will be very useful. Okay, later we will see how it will be very useful. We can understand this. This is going to be 0. Well, we can go ahead and see another problem. Okay, now you can see other problems on solid angle. I'm making this topic lecture on this topic. So pertaining to solid angle, next problem is that a point charge Q is at the origin of a spherical coordinate system, a spherical coordinate system. Then find the flux which crosses a portion of a spherical cell. A spherical cell described y alpha is greater than theta is equal to beta. Okay, now theta is given within this range. Okay, this is your question. Okay, now what if alpha is 0 and beta is pi by 2? Then find the answer. First express the flux for this angle. Okay, you know the total flux psi, or you can say phi, crosses the complete 4 pi r square area. Okay, but for the stripe, okay, 4 pi r square area, and for this stripe, what is the area for this stripe? Then you can use the unitary method to find the flux. If you can find this area, this is the flux. Okay. What is the area of the stripe within this angle, range of the angle? Area of the stripe for a spherical coordinate system, which is r square sine theta, d theta and d phi. In previous classes we have how it comes. I have explained it. and theta, this is going to vary between alpha and beta, and d phi, this is 0 to 2 pi. Okay, we need simple. Okay, d phi, integration of d phi is equal to 2 phi. This 0 to 2 pi is integrable over the d phi is this angle, then we have 2 pi r square sine theta. Of course, the integration of sine theta is cos theta minus cos theta. Then you can write change आप इसे चेंज कर दें, इंटीग्रेशन को लिमिट उसे चेंज कर सकते हैं क्योंकि माइनस आ जाएगा, तो आप चेंज करके इसे पॉजिटिव कर सकते हैं. यू कैन राइट cos alpha minus cos beta. This is the area of the stripe. Okay, this is expression for area of this stripe over a spherical cell. So flux through the stripe, then the flux through a stripe. You can write by routine method. You can find this like area by 4 pi r square into q. Big R, because you're using bigger capital R, so I can express it with both terms should be expressed with the same big R. Then what you have, q for 2 pi is going to be cancelled out. We have q by 2 and cos alpha minus cos beta. This is the flux through this stripe. Well, we can put this, second result, alpha is 0 and beta is pi by 2. You will get 1, alpha 0, 1, and this is going to be 0, 90 degree. We have flux, q by 2. And this, well, this is the net flux. We can do some other problems on this topic. So, the question is, ये uniform line charge of density L represent length. We have 3 microcoulomb per meter lies along z axis and concentric circular cylinder of 2 meters has and charge density. Cylinder has charge density minus 1.5 negative by 4 pi, okay, microcoulomb per meter square. Both distribution are infinite in extent with Z. Okay, you can see that both distribution are infinite with Z axis. Then find D in all region. Okay. Look at the beauty of these equations I have just given you. That is D. Okay, if you know the D, you can easily find the electric field, just dividing by permittivity of the medium. Okay, now you see the charge distributions. Okay, two charge distributions. Now, Gauss law. So this is the question here. Now, this is wire along z-axis. It is really infinite, and we have one cylinder. And another one concentric, and this is your charge density in length. It was 3 microcoulomb per meter and this is the cylinder. So this have charge distribution is delta S have negative charge minus 1.5 4 pi charge per meter square. It is in microcoulomb. It is in microcoulomb per meter square. So we have to find and circular cylinder of radius 2 meter. Okay, what is the D? You know that D is charge per unit length by 2 pi r. Okay, because electric field into permittivity, as we know that electric field is charge distribution 2 pi permittivity into R, and permittivity into E is D. Okay, so this is your D, and this is in radial direction. AR stands for radial direction along R, and we have R. This is okay, and we have to calculate the variation of D using this Gauss law within this radius, or also R is greater than 2. Okay, this is the region where I want to find the D. So, you know, the charge enclosed is nothing but integral performed of this D. Okay, we consider two region. When you consider outside this, R is radius, when R for R is greater than 2, we have two charge sources. Okay, we have charge enclosed. What we have charge enclosed? This is charge per unit length, and we have 4 pi delta S. This is for cylinder. Okay, and we can perform D, and this will be also cylindrical surface over which ds is going to be performed, because the cylinder is going to be symmetrical, with this axis. So it will be also 2 pi r and l, and this is into multiplied by l. This is integration multiplied by l gives you the total charge. Okay. L is going to be cancelled out now by D have density L plus 4 pi density S by 2 pi R. R is outside, and this is your direction. This is 4, R is greater than 2. Okay, for R is less than 1, you consider only one charge. Okay, you can same way you can find D. So if you know only the total charge enclosed, you can find the D, and from D you can find the electric field very easily, because this is relationship between electric field and D. So you now look at the importance of the Gauss law. You can understand through the flux you can find the electric field, not through the force analysis, not through making any complex integration with the charge distribution, and with not through vector, not through a scalar, using a scalar potential. So you can also find the electric field with potential. Next chapter I will teach you potential and and how potential is related with the charge distribution. We'll see there's some differential equations, like Legendre, Poisson's equation, Laplace equations, and Bessel functions. But right now this is your D. It's very easy. Now it will become very easy if you can use these tools. Okay, so again do other problems. कुछ और नया प्रॉब्लम करते हैं इसी टॉपिक्स पे. हम लोग अभी देख रहे हैं कि डी का कैसे यूज करते हैं इलेक्ट्रिक फील्ड निकालने के लिए. यदि आपको डी पता है गॉस लॉ के थ्रू, और चार्ज इनक्लोज जानना कितना आसान है. आप किसी भी कोऑर्डिनेट सिस्टम इंटीग्रेट कर दें, आपको चार्ज इनक्लोज निकल जाएगा. तो आप इलेक्ट्रिक फील्ड भी निकाल सकते हैं. Okay. Now, a charge configuration is given. A charge configuration in cylindrical coordinate is given y charge distribution is given by the function 5r e to the power minus 2r. This is exponential e to the power minus 2r. Look at this expression. Can you find the electric field by Coulomb's law? Do you have any idea about the distribution of this function? Perhaps not, it's very tough. But using Gauss law and this property, electric displacement d, you can easily find the desired, what do you want to know? Actually, you want to know, find d. Okay, so find d. This is a very easy question now. Okay, just I am making you understand how to write this expression in cylindrical coordinate. Okay, we have learned in a spherical coordinate. So just I want to make you fix your attention here and form on the expression of writing this in certain coordinate system. Here we have circular coordinate system. So d dot ds performed over lateral surface. Okay, let me write lateral surface. Okay, this will give the charge enclosed, and charge enclosed we have 5r e to the power minus 2r, and r dr, this is a unit area over the cylinder. Suppose we have a cylinder, okay, and yes, we are making this small area dA, and this is length. Okay, so let me enlarge it. dz with r dr, d theta and dz, because here coordinate is r, theta and z. Z is the length of cylinder. Well, you can express write the integral value 0 to r radius, and for d theta of course it varies from 0 to 2 pi because it's a circle. Look at this is the circle, this length. Okay, and angle, this is the point and this is your angle. Okay, and this is the phi. It will rotate this angle 2 pi. It will rotate 2 pi, and dz is from 0 to L length. This is your charge enclosed. Okay, this is the R, so we can write d into 2 pi r L. L is going to be cancelled out, so we can write this integral value as, you can perform the integration by part. Okay, you can do yourself integration by part. You will get 5 okay, you can get 5 into 2 pi into L, and from 0 to r we have r square e to the power minus 2r dr. Now you can integrate it using integration by part. and this is going to be cancelled out, and 2 pi is going to be cancelled out. So we have now d is equal to 5 to r square e to the power minus 2r. You can use the integration by part to solve all these problems. Okay, you can find the d after this calculation. You can do yourself. ओके, इसी टॉपिक से फिर से एक और प्रॉब्लम करते हैं ताकि हम इस कोऑर्डिनेट सिस्टम यूज करने की अच्छी तरह से समझ जाए। यदि आपको कोऑर्डिनेट सिस्टम यूज करना आ गया तो अभी हम आगे पढ़ेंगे इस कोऑर्डिनेट सिस्टम से हम जब डिराइव करेंगे, जब हम पोटेंशियल और कार्टेशियन कोऑर्डिनेट में जब लैप्लास को सॉल्व करेंगे तो आपके लिए बहुत यूजफुल होगा। यहाँ जो पढ़ रहे हैं आगे लिंक है, वहां पे कनेक्ट करेंगे, वहां पे काफी फास्ट होना चाहिए तो ताकि मैं लिख सकूं यहाँ पे, I can write very easily without hesitation, that are not skipping the step. Okay, I am making slowly, okay, driving you slowly. Okay, this is drifting, not randomly I'm doing. So its topic should have some connection. Okay, now last problem we can do, determine the flux crossing 1 mm y 1 mm area on the surface of cylindrical shell, on surface of cylindrical shell at r is equal to 10 meter, z is equal to 2 meter, and phi is equal to 53.2 degree. If we have given d, okay, 2ax, you can consider it, 2x ax plus 2 1 minus y plus 4z az. This is the vector coulomb per meter square. Okay, and this is your angle phi. Okay, here आप देख सकते हैं यहाँ पे हम किस तरह सिलेंड्रिकल कोऑर्डिनेट का यूज करेंगे, और फ्लक्स तुम जानते हैं फ्लक्स होता क्या है, जब गॉस ला यूज करेंगे तो हम आसानी से निकाल सकते हैं। इस क्वेश्चन से आपको सिर्फ सिलेंड्रिकल कोऑर्डिनेट कैसे यूज करते हैं ये आपको अच्छी तरह से आ जाएगा, क्योंकि ये बेसिक है, आगे इसका भरपूर यूज आने वाला है, तभी आप इलेक्ट्रोस्टैट को गहराई से समझ सकते हैं। क्योंकि वहां पे हम बहुत फास्ट लिखेंगे, वहां पे ये नहीं बताएंगे कि ये स्मॉल एरिया है और इसका फ्लक्स क्या होगा, डी क्या यूज कैसे करेंगे। अब देखिएगा, आप सिलेंड्रिकल कोऑर्डिनेट ये सिलेंडर है और एंगल कितना दिया हुआ क्वेश्चन में, एंगल दिया हुआ, हाँ 53.2 डिग्री। ओके, और जेड बराबर 2 मीटर दिया हुआ है, आर बराबर 10 मीटर दिया हुआ है। ठीक है, देखो यदि हम जेड इसे मानते हैं और y इसे और एक्स है, तो एक्स वाई जेड कोऑर्डिनेट है हमारा। और यहां से जो एंगल है, ये एंगल हमारा दिया हुआ है 53.2 डिग्री दिया हुआ है, ठीक है, ये एंगल। और यहां पे एक हमारा, हम लोग 1/1 का एरिया लेते हैं। ओके, ये पॉइंट हम लोग देख लेते हैं। ये पॉइंट इस तरह से पास होगा, ये 1/1 का जो एरिया, इससे फ्लक्स कितना पास होगा। जबकि डी हम लोगों का दिया हुआ है, डी का एक्सप्रेशन क्या था, डी जो है 2x ax प्लस 1 माइनस y ay प्लस 4z az कूलम पर मीटर स्क्वायर, ये दिया हुआ है आपका, डी दिया हुआ है। तो इस एरिया से कितना फ्लक्स पास होगा, ये आपका क्वेश्चन है, ठीक है। देखिए फाई दिया हुआ है तो एक्स आपको आसानी से निकल जाएगा। यदि फाई दिया हुआ है देन यू कैन फाइंड एक्स एंड वाई कोऑर्डिनेट। सो आप किसी पॉइंट को पी मान लेते हैं, तो पी का कोऑर्डिनेट कितना होगा, मतलब एक्स कोऑर्डिनेट क्या होगा, रेडियस कितना दिया, सॉरी रेडियस 10 दिया हुआ है, तो एक्स कोऑर्डिनेट कितना होगा 10 cos 53.2 डिग्री एंड y कितना होगा 10 sin 53.2 डिग्री। क्वेश्चन में इसका वैल्यू दिया हुआ है, ओके, वो हम नहीं लिखे, पर इसका 6 हो जाएगा क्योंकि 0.6 है और ये 0.8 है, तो इसका 8 हो जाएगा। ओके, cos 53 डिग्री है, 0.2 डिग्री से फर्क नहीं पड़ रहा। ओके तो x कोऑर्डिनेट आपका y कोऑर्डिनेट यहां पे दिया हुआ है इस पॉइंट पे। अब देखिए x है y है, तो हम यहां x पुट कर सकते हैं, तो d निकल जाएगा हमारा। d क्या हो गया 6 12 ax 2 इंटू 1 माइनस कितना दिया हुआ 1 माइनस y कितना हो जाएगा 7 और 14, सॉरी निगेटिव में, माइनस 14ay और ये देखिए 4z, सॉरी ये z कोऑर्डिनेट है, तो 4z यहां पर क्या होगा 4 इंटू जेड, जेड कोऑर्डिनेट भी हमारा दिया हुआ है 2, तो कितना हो जाएगा हमारा 8 हो जाएगा। दिस इज 8az। ओके, सो x कोऑर्डिनेट में इसका वैल्यू, x डायरेक्शन में इसका वैल्यू 12 है और y माइनस 14 है और z में इसका 8 है। ओके, अब कोऑर्डिनेट निकाल दिए, फिर यहां पर वैल्यू पुट कर दिए, हमारा d आ गया। वो x वेरिएबल था, y वेरिएबल था, z वेरिएबल था, उस टर्म में था, तो हमारा खत्म हो गया। अब हम एरिया क्या है 1/1, तो हमारा ds क्या होगा, ds तो था 1/1 mm by 1 mm था ना, तो इसका वैल्यू हो गया 1 mm स्क्वायर। जो पैच है तो इसको भी वेक्टर के टर्म लिखना पड़ेगा, क्योंकि ये वेक्टर है, तो ये वेक्टर है, सॉरी ये आपको पता है ना वेक्टर है, दिस इज वेक्टर क्वांटिटी, तो ये भी वेक्टर है, इसका आप लिख सकते हैं दिस इज एरिया वेक्टर ए, इसका एरिया वेक्टर इधर होगा। हाँ, तो एरिया वेक्टर कितना हो सकता है इसका, हाँ लिख देते हैं, इसको मीटर में कन्वर्ट करेंगे तो हो जाएगा 10⁶ मीटर स्क्वायर। और इसमें x कोऑर्डिनेट और y कोऑर्डिनेट क्या है, तो x कोऑर्डिनेट और y कोऑर्डिनेट के टर्म में हमको लिखना होगा। छत्तीस से 64 10। ओके, इसे हम रिजल्टेंट निकालेंगे इसका, तो कितना होगा r, रेडियस 10 ही है, तो बराबर हो जाएगा 0.6 ax प्लस, हम इसे यूनिट वेक्टर में कैसे लिख सकते हैं, इसका x कोऑर्डिनेट बाय टोटल मैग्नीट्यूड हमारा यूनिट वेक्टर में आ जाएगा, तो 0.6 हो गया और ये भी 0.8 हो गया, ये यूनिट वेक्टर है। ओके, इस क्वाड्रेंट पे यूनिट वेक्टर x इतना है, y इतना है, तो हम जब रिजल्टेंट से डिवाइड कर देंगे तो हमारा यूनिट वेक्टर इस डायरेक्शन में चला आएगा। तो रिजल्टेंट तो 10 है, तो हमारा ये हो गया यूनिट वेक्टर। तो ये हो गया हमारा एरिया जो वेक्टर फॉर्म में आ गया। अब हम फ्लक्स निकालना चाहते हैं, डिफरेंशियल फ्लक्स। तो हमारा फॉर्मूला है गॉस लॉ को d डॉट ds, हम लोग वेक्टर प्रोडक्ट करेंगे, सॉरी डॉट प्रोडक्ट करेंगे, जो वेक्टर है वेक्टर का डॉट प्रोडक्ट करेंगे। तो हमारा दो वेक्टर है, उससे हम डॉट प्रोडक्ट कर सकते हैं। ओके, तो हम देख लेते हैं x यहाँ दो ही क्वाड्रेंट है, एक क्वाड्रेंट यहाँ पे 0 है, तो वो z तो हम लोग को मिलेगा नहीं। ओके, आप कर लगे, आपका आंसर जो है वो हम लिखते हैं। आप इसे और इसे मल्टीप्लाई कर दें और इसे मल्टीप्लाई कर दें और घटा दें, तो आपको आंसर आ जाएगा फ्लक्स का -4 माइक्रोकूलम। ओके, लुक एट दिस, फ्लक्स जो है हमारा वो चार्ज के टर्म में आ रहा है, बिकॉज दिस इज चार्ज इनक्लोज्ड, चार्ज enclosed. Negative signs, what is the meaning of the negative sign? Okay, negative signs means not outward, inward. Okay, inward हमारा flux है, flux negative signs enforce that flux is inward, not outside. Okay, just I am trying to make you the use of cylindrical coordinate system and capitalizing this concept over Gauss law, because it will be very useful in later section. You will see how it is useful. Thank you for now. I think I have made you understand the Gauss law in spherical cylindrical coordinate. Thank you.